Please welcome Monica, who's going to talk to us about mathematical resilience as a coping mechanism for statistical anxiety. Thank you, Monica.
Thank you. Thank you. Good afternoon, ladies and gentlemen. Receive greetings from Kenya, and thank you for this opportunity. My name is Monica Agunda from the University of Nairobi. I will be presenting on, I am presenting on exploring mathematical resilience as a coping mechanism for statistical anxiety among Kenyan postgraduate students. So first, I will introduce myself, a bit of my background. I currently work as an administrator in the postgraduate office of the Faculty of Education, where teachers are trained. I am also a PhD student at the university, that is JKUAT, Jomo Kenyatta University of Agriculture and Technology. Okay, by the nature of my work, I have worked in this office since 2021, and the nature of my work, I interact with most postgraduate students, usually at the exam level. We call it defense, and most of these students are adult students, 40 years and above. So I act as an advisor to most of them, and my years of experience working with them, I have noticed that they seem to be in the red zone when it comes to exam, and most of them would say, no, I'm not ready for the defense, please reschedule. Some of them delay, they take so long before they graduate because of statistical anxiety. Currently, we have a student who was sponsored by Dad in 1993, and is still not able to graduate. So we are trying to push him and see if he can be assisted to graduate. Now, about statistics, you realize that in Kenya, students interact with statistics at TVET level, at tertiary level. That includes TVET, polytechnics, and universities. When they are at secondary school level and primary levels, they do mathematics.
Can I just interrupt for a minute? Have you moved on with your presentation? Because we're still on your first page.
I've not moved on.
You've not moved on. Okay, sorry, apologies. Apologies.
Okay. It's okay, I had not moved on. Just a bit of the background. So it's also important to note that placement of universities, we tend to have many students moving into social sciences and not STEM courses. That makes majority of students not to get exposure to statistics. And you get exposure to statistics, some undergraduate courses would expose you to statistics, but not all. And then you get exposure to statistics at master's level and at PhD level. So this may be a reason for the level of anxiety that students experience. Another thing that happens is that statistics is usually offered students as a common course. So you find the class, and when the class is full, a lecturer would teach and ask, did you understand? Everyone says yes, and life goes on. So when it comes to application of these statistics, it just becomes a challenge, and students experience anxiety. So to my introduction, we say resilience is the ability to cope with academic demands, stress and pressures. That is according to Mwangi and Laiko. And mathematical resilience refers to the ability of an individual to persevere and adapt to challenges or challenging mathematical tasks, maintaining a positive attitude towards learning. In Kenya, students begin learning statistics. I had briefed about that, so I don't have to repeat, and about placement of students, where we have more students going social sciences, where they don't get exposure to statistics. They only get exposure to it at a later stage. And students require supportive learning environment and positive teacher-student relationships to foster resilience. That is according to Lee and Wilder 2017. I go to my statement of the problem. The increasing demand for data-driven decision-making has heightened the significance of statistical knowledge, particularly among postgraduate students. And in Kenya, the mastery of statistical concepts is crucial for academic success and professional development.
Monica, I'm so sorry to interrupt. Are you still on your first slide?
No, I have moved on.
It hasn't moved on our screen.
Oh my, sorry. Let me try and end this and move to another. Okay.
That's it.
You let me know?
Yeah, main objective of study.
Okay. So I was, sorry for that. I was at the statement of the problem and I had introduced part of it. So I go to continuation of that and we say, however, many students experience significant anxiety when engaging with statistics, which can impede their learning and academic performance. And mathematical resilience, defined as the ability to persevere and adapt in the face of mathematical challenges, offers potential coping mechanisms for this anxiety. The objective of this study is to explore mathematical resilience as a coping mechanism for statistical anxiety among Kenyan postgraduate students. We have 5 objectives of the study, that is to assess level of anxiety experienced by the postgraduate students, to examine the relationship between mathematical resilience and the ability to cope with statistical anxiety, and then to identify factors contributing to mathematical resilience. Then we explore strategies and interventions that would promote mathematical resilience to reduce anxiety in students. And finally, to establish strategies employed by students to overcome statistical analysis. The last objective of the study, I used focus group discussions to get the strategies that are employed by the students. I go to my next one. I used Albert Bandura, social cognitive theory, which explores the interplay between personal factors, behaviors, and environmental influences. That is, we look at self-efficacy and observable learning. Methodology, I used mixed method approach, combination of qualitative and quantitative. Where quantitative, I circulated for pilot study and did focus group discussions as pilot study towards this study. The target population, according to Q, is that we have about 50,000 postgraduate students in Kenya. So the sample size was 385 using Fisher formula for populations above 10,000, and a sample of 38 was picked for the pilot study. I used Google Forms to circulate the questionnaires for the pilot study, and I used Google Meet to hold the focus group discussions. So the key points from the pilot study, my first objective was to assess level of anxiety in statistics experienced by the postgraduate students, and we see high levels of anxiety are common, with significant worry about failing courses and feeling overwhelmed by content. The next one was to check the relationship between mathematical resilience and the ability to cope with statistical anxiety. And this one shows also that there would be higher resilience associated with better coping mechanisms. The responses to this question generated, remember the results I have are just descriptive statistics, nothing inferential at this level. So it generated a mean average of 2.578. The other objective was factors contributing to mathematical resilience. We had questions on academic support systems, that is access to tutors, study groups, supportive instructors, and peers. And this generated an average of 3.7%, which moved towards disagreement with the statements. So on self-efficacy beliefs, that is confidence in one's ability to succeed despite challenges, the respondents also tended to move towards neutral. Some were saying yes, some were saying no. So it is a neutral response. Then we have previous mathematical experiences where we see both positive and negative experiences influenced resilience. So statement, strategies and interventions, that was my objective. And the strategies include workshops on resilience building, peer study groups, breaking down complex problems into simpler versions so that they are manageable. Then we have regular feedback from instructors to motivate the students on the positions. And then we have fostering a positive mindset. And this generated an average mean of 1.21, meaning the respondents agreed that such strategies would help them move from the panic zone to the comfort zone, or not even the comfort, but the middle zone. Those are terms I've learned from this workshop. I didn't know them before. So the findings from focus group discussions, that is strategies employed to overcome statistical anxiety. Here I got all sorts of responses where find students saying there's over-reliance on memorization. So students try to cram, to memorize before a defense. And usually when they come for these defenses, what you see is a very good presentation from the beginning to the end. But the moment they start interacting with the panelists and they are asked questions, especially chapter 4, where statistical analysis is, you find students getting confused, and then sometimes they even leave the defense. At the end of the defense, they leave not knowing whether they passed or not. So when you call them and you tell them you have passed, they wonder, I didn't expect to pass. So because of this, it makes most of them not able to perform well, and this delays their graduation. And then there's procrastination. You find students just delaying and avoiding statistical assignments, leading to increased stress during performance of the exams. There's also avoidance, where you find them skipping classes. And here we look at students who, postgraduate students who do masters and PhD by coursework, because students who do thesis only submit proposals, they don't attend classes. But those who do PhD by coursework attend classes, and they also do statistics. So you find some of them skipping, and in this skipping, some of them even tell you, no, I'm not ready for the defense, please reschedule it, take it to another date, and this brings about delays. So other strategies, we find the dependence on others, where most of students, including myself, when it comes to inferential statistics, we are not able to do most of it. So you find yourself giving it out to someone to do it for you. And then sometimes they make mistakes, and because you don't. So during your defense, a person who understands statistics will ask you, what do you mean by R square equals to this? And you get thrown off balance. You don't know what to answer. You don't know exactly what to say. So this affects performance. And then we have negative self-talk, where students engage in defeatist, I'm not good in math, I'm not good in statistics. So this also undermines them and reduces their confidence in statistics. So we have also those who cheat. And in Kenya, some of them will tell you, degree ni harambe, meaning we work on it together, so we can copy, and present. So these are negative traits which some students use. Some students go into isolation where they withdraw. I remember at one point we had a student who defended and he didn't know that he passed. So he went and we were looking for him. He said he was so stressed that he didn't want to talk to anyone. Then we have also ignorance of availability of resources. And then the last one, we have substance abuse, where you just find students getting so stressed and getting into substance abuse in order to reduce that anxiety. And this is not good for mental health and even their health in general. So implications for practice and policy, we talk about implementing peer mentoring programs. We provide additional resources for students and integrate resilience-based activity to the curriculum. Policy recommendation, advocate for systemic changes to enhance support mechanisms across universities in Kenya, and develop targeted interventions to support student mental health and academic resilience. So conclusion, contribution to literature. This study will provide insights into the role of mathematical resilience in coping with statistical anxiety. Recommendations: by understanding and addressing factors influencing resilience and anxiety, institutions can create more inclusive and supportive learning environments. Future impact: the study will impact on students positively if implemented, so that we have students moving from the anxiety zone to the comfort zone, or the study zone. Let me see, it's called what zone?
The learning zone.
The learning zone. Thank you. So we end by looking at a few maths memes in Kenya, where the first one, you're looking at a mathematics student going to class, carrying sticks. These memories, when people think of what they went through in mathematics, you just don't like it. The second one, you're seeing as a lecturer or as a teacher teaching, and the class is flooded. But he's saying, before it gets to your next, I must introduce vector, you know? So such. Then the third one, you're looking at a mathematical teacher spying onto the class. What exactly are they saying? And they said this can only be done by a mathematics teacher. So the fourth one, we are seeing a student who was prepared. And in Kenya, when it is PE, in some schools, it's the same uniform, you will go with to PE. So this student was ready to go for PE. And then a mathematics teacher walks in. So he's resisting. He's not ready for mathematics. He wants to go out for PE. The fourth one, we are seeing a mathematics teacher. Regardless of the floods, he is ready and going to teach. And remember, as students, they are not ready. Students are not ready for mathematics when it rains. Even if it is on a normal day, they are not very ready for mathematics. So this now brings me to the end of my presentation, and I say thank you for listening to me.
Thank you very much.